Hello everyone, so in this video we'll talk about the other types of the mean. First, the arithmetic mean, which is the same as the x bar we saw in the last videos. The second type is geometric mean, and the third part is harmonic mean. So no need to talk about arithmetic since it is the same as x bar. So let's talk about geometric mean first and then harmonic mean. So for the geometric mean, first I will give you the formula, and then after that I will try to explain how this, from where actually we got this concept of geometric mean. So geometric mean is used for growth rates and percentage. Example, investment returns, population growth, inflation rate, interest rate. So whenever you see something growth, some like growth or something growing compoundly, it means you have to use the geometric mean. So first I will give you the formula. So the formula for the formula for GM or geometric mean is GM equals the nth root of the product of all your data points in the data set. In another word, it is the nth root of x1 times x2 until xn. We can write it like this. So it is the nth root of the product of all your values, or also you can write it like this. It is the same thing. It's the product of all your data points, then power 1 divided by n. In case you have organized data, which means you have frequencies, you use this one, which is the product of xc power fe and the result power 1 divided by the sum of frequencies. I will give you another formula which is useful when you have large numbers. So you take the logarithm of GM. So log GM, since GM is this, so the log of GM equals the log of this or the log of this in case you have frequencies. And from the properties of the log, we get this formula. So log GM is actually the sum of fe times log xe divided by the sum of fe. Since we want actually GM, not log GM, so GM is simply 10 power log GM, this one, which is the sum of log xe. So if you have frequencies, just use this one. You don't have frequencies, use this one. So there is no problem with this. And now let's see an example, so that first we apply this formula and also to understand this concept. Okay, so now imagine that an investor placed money in a mutual fund for 3 years. The fund produced the following annual return. So the first year the return here is 12%. For the second year it is a loss, minus 8%, and in the third year it is 5%. Let's find the average, or which means the geometric mean here. We cannot use the arithmetic mean. So how to find let's first find the average, then you will see that the average is the same as the geometric mean. So imagine that the initial investment is $1,000. So at the end of the first year, this investor will have actually 1,000 times 1 plus the rate of return, which is 12%, 0.12. At the end of the second year, this investor will get actually what we have in the previous years, which is this, times 1 plus the rate of return, which is minus 8. So that's what he get. At the end of the third year, he will get actually what we have in the previous year, which is this, times 1 plus the return of the third year. So in the end of this investment, in the end of the third year, this investor will get 1000 times 1 plus 0.12, which is 1 plus the return rate of the first year, times 1 minus 0.08, which is 1 plus the rate of return for the second year, and finally times 1 plus 0.005. Actually, we call this the growth factor. 1 plus the return rate is called the factor of growth, or growth factor. So now, what does it mean find the average return? Actually, when we are trying to find the average here, it's like we are looking for a single average rate, a single rate of return that would give us the exact same final result if applied every year for 3 years. Which means we know that this investor got for 3 years this value. We want, instead of different growth factor, we want only one single growth factor. So all this equals actually $1,000 times 1 plus the rate here, the average rate, or the single rate, power 3, because it is this times this times this, which is power 3. So we can cancel 1000 with 1000, then we get 1 plus the interest, 1 plus the interest, power 3 equals the product of 1.12 times 1.92 times 1.25. Then we can remove power 3 here and place it here as 1 divided by 3. Okay, so 1 plus the interest, which is the factor growth, equals actually the product of all the other factor of growth, 1 plus the RI, power 1 over the number of periods here, the number of observation here. Observation is a period, so 1 divided by 3. So if you remember the formula of the geometric mean, this is exactly the formula. This is it. So let's check it here. So here is the geometric mean formula, and it is the same thing as this one. So 1 plus R, which is the factor growth, is actually the first factor of growth times the second times the third, and all this power 1 divided by 3. Then if you want to get the exact rate, you can so as I said, you can just if you want the interest rate or the rate of return, we can deduct 1 from the factor of growth, because the factor of growth is 1 plus R. So R here is 1 minus the factor of growth minus 1, and here it is 1.0266 minus 1. We will get this return as the average, 0.0266. So next time when you see anything related to growth, something that is growing compoundly, don't use all those steps. If you want to find the average, just apply GM. Apply directly the formula of GM. And however, to replace XC here, don't use directly the other rate. No, use 1 plus R, the factor of growth. Once you have found the average factor of growth, then you can find the rate by deducting 1. So factor of growth minus 1, you get the interest or the return of the rate of return for this example. So this is it for the geom or the geometric mean, and in next video we will talk about the harmonic mean and when it is useful. Thank you for watching and good luck.